So let us look at a few prerequisites before going further. These are nothing but elementary, let's say high school level mathematics. Precisely speaking, it is matrix multiplication, and we'll understand what happens when you multiply a matrix. Although you would have understood what is matrix multiplication, you wouldn't have seen this part that I'm explaining next. Observe carefully. It's a very interesting observation you can make about matrices. Okay, so let us look at this very elementary matrix question. You take a matrix 1, 2, 3, 4. Alright, we're going to play around this matrix only, a simple 2 cross 2 matrix. Right? Multiply it with this vector 1, 1. What do you get? You simply get 1 plus 2 and then 3 plus 4. Right? Fine. We all understand this much of matrices at least. Right? Okay, next. This is equal to 3, 7. So 1, 1 is giving rise to 3, 7. Right? Good. And then let me see how can one represent points on this two-dimensional plane, two-dimensional coordinate system. Okay. So we got 3, 7, right? Now let me take a point 5, 4 somewhere in this coordinate axis. I will tell you what one means by pulling this to a circle. Okay, you will understand it very soon. It's a very easy concept. So look at the vector of this depicted by this point 5, 4. It's simply the line joining the origin and 5, 4. Right? And now what I do? I draw a unit circle. What do you mean by unit circle? By this you mean, what's a unit circle? By a unit circle we mean a circle with radius 1, with center as origin. Right? So what happens next? Here is a quiz question for you all. Can you compute what is this point? This very point here? What is this point? Pause the video and then compute this. Please note, I have given you a point 5, 4 and I am giving you a unit circle and I am asking you where does this line joining the origin and 5, 4 intersect the unit circle. Right? This is some basic thing. You compute the coordinates of this point. Extremely basic. Right? What you do is you first write 5 and then divide this by the square root of the sum of the squares. Right? We all have seen this. Take a minute's pause and then observe this if you are unable to see this. It's a very high school level coordinate system mathematics. Nothing beyond that. And then you have similarly 4 divided by square root of 5 squared by plus 4 square, and this is your point on the unit circle. Given any point a comma b, you can write the corresponding point intersecting the unit circle in the same direction as a divided by square root of a square plus b square. Here a is 5 and b is 4, and 4 by b by square root of a square plus b square. Alright, particularly I showed it for the example 5, 4. So far so good. You all understand what has happened so far. Let us observe something. A very obvious observation is that both the points are in the same direction. Right? They are both in the same direction. Correct? From origin, if you can see, this these two vectors 5, 4 and 5 by square root, 4 by square root, both of them are in the same direction. Now, let me look at what just happened before. We took let me repeat this. It was an elementary matrix question, and we took matrix 1, 2, 3, 4 and multiplied with 1, 1. We got 3, 7. Right? Now, what do? I take this 3, 7 and then try to see what is the point on the unit circle in the same direction. What do I mean by this? Just now we did that before, right? Before the previous video that I showed you, whatever we did here, I'm going to ask you to do the same thing for the next slide. 3 by 7, when it's pulled to the unit circle, will give you so much, right? Again, a divided by square root of a square plus b square and b divided by square root of a square plus b square is the corresponding point on the unit circle. What is this equal to? Let me compute. I use my calculator and I saw this comes out to be 39 and 0.91. Good. What next? What now? I multiplied 1, 2, 3, 4 with 1, 2. I'm sorry, 1, 1, and I got 3, 7, and I sort of, this is called normalization. I normalized it. I got this value on the unit circle. What if I continue doing this process? Right? I got this 3, 7. I continue this. I pull it to the unit circle. I got so much. What if I take these two things? Look at this from the previous slide. I simply take this 0.39 and 0.91 and I apply 1, 2, 3, 4 matrix on it. Okay. What do I get? I get, my calculator says I get 2.21 and 4.81. Again, I repeat this process. I normalize this and I see as I keep repeating this process, what exactly do I get? So what did I see? I took a matrix, applied it to a vector, I got another vector. So a vector, a matrix, I got another vector. What I do is I take this matrix and apply it to the same vector. Now before that I sort of, I normalized it. Normalizing is just to ensure that you don't get bigger values. All you care about is the direction. Okay, I'll tell you what I'm trying to do. And I get a new vector, another vector. Let's say this was vector 1, this is vector 2, and now you get a vector 3. Alright, and then again apply this matrix on this vector, you get a vector 4. At every instance you are normalizing. By normalizing I mean you pull it to the circle and you see where exactly this is going. Somehow we seem to be interested in repeating the same process again and again, and we see what happens. We saw what happened with the iterated value of this matrix. Remember 1 by 3, 1 by 3, 1 by 3, not of the matrix, that of the graph. We took a graph with 3 nodes, we assigned the values 1 by 3, 1 by 3, 1 by 3, and we saw that it converged. And now we are asking a matrix question. It converged, right? Now we are asking a matrix question, right? When you apply a matrix repeatedly on a vector, what happens to it? Will it also converge or not? Obviously, when you apply a matrix like 1, 2, 3, 4 on a vector, the values become bigger and bigger, and that is why I'm trying to pull it back to the unit circle, right? I'm normalizing it. What I'll do is I'll switch to screencast mode and I'll try to understand this matrix multiplication process nicely.